Red giant. If the sun were suddenly replaced by a red giant star, the first and most immediate effect would be its immense size. A red giant is a late-stage star that has exhausted the hydrogen fuel in its core, causing the outer layers to expand massively. Typical red giants swell to between 100 and 1,000 times the sun's radius. That means instead of being 1.4 million kilometers across, it could expand to hundreds of millions of kilometers, large enough to engulf the orbits of Mercury, Venus, Earth, and possibly even Mars. Red giants also shine with much greater luminosity than the sun, sometimes thousands of times brighter. However, their surface temperatures are cooler, often ranging between 3,000 and 4,500 Kelvin, giving them their reddish-orange glow. For Earth, this balance of immense size and increased luminosity would be catastrophic. If Earth were not already swallowed by the star's expanding atmosphere, the intense heat and radiation would boil away the oceans, strip the atmosphere, and render the planet completely uninhabitable in a matter of days. From a gravitational perspective, the core mass of a red giant is often similar to or slightly less than the sun's. This means orbital mechanics of the outer planets would remain relatively stable. But the sheer size and energy output of a red giant in place of our sun would erase any possibility of life in the solar system as we know it. White dwarf. If the sun were swapped with a white dwarf, the solar system would be left with a stellar remnant roughly the size of Earth, but nearly as massive as the sun. White dwarfs are the end state of stars like our sun. After exhausting their nuclear fuel, they shed their outer layers and collapse into an ultra-dense core. A white dwarf packs around one solar mass into a sphere only about 12,000 kilometers wide. The light output of a white dwarf is a fraction of the sun's. With no sustained fusion reactions, its faint glow comes from leftover thermal energy. The surface temperature can exceed 100,000 Kelvin initially, but it steadily cools over billions of years. For Earth, the reduced radiation would plunge the planet into a deep freeze almost instantly. Oceans would freeze solid, and the atmosphere would collapse under the extreme cold. Gravitationally, the white dwarf would exert nearly the same pull as the sun, so planetary orbits would remain stable. But with so little energy output, life on Earth or elsewhere in the solar system would vanish almost immediately. Neutron Star. Replacing the sun with a neutron star would create one of the most extreme transformations possible. A neutron star is the collapsed core of a massive star that went supernova. Despite having about 1.4 times the mass of the sun, it is only about 20 kilometers in diameter. That means it is so dense that a single teaspoon of its matter would weigh billions of tons. A neutron star's gravitational field is incredibly intense, but because it retains a similar mass to the sun, planets would likely stay in orbit. However, the radiation environment would be lethal. Many neutron stars emit intense beams of radiation as pulsars, sweeping across space like cosmic lighthouses. Any planet in the habitable zone would be bathed in deadly X-rays and gamma rays, sterilizing its surface instantly. The lack of steady light and heat would plunge Earth into darkness and cold, and the extreme radiation bursts would make survival impossible. The solar system would remain intact structurally, but biologically, it would become completely hostile. Black hole. If a black hole of equal mass replaced the sun, the gravitational effect would be almost identical. Earth and the other planets would continue orbiting as usual, since black holes do not suck in matter any more than any star of the same mass. However, the absence of light and radiation would be devastating. Within hours, Earth would be shrouded in freezing darkness. Over weeks to months, global temperatures would plummet hundreds of degrees. Oceans would freeze from the top down, and the atmosphere would condense into liquid nitrogen and oxygen. Eventually, Earth would become a frozen, lifeless rock orbiting an invisible gravitational well. If the black hole were smaller but still massive, like a stellar mass black hole only a few kilometers across, the event horizon would replace the sun's visible disk. The solar system would effectively orbit a point of infinite darkness. and any object that drifted too close would be stretched and torn apart by tidal forces in a process called spaghettification. Blue giant. Swapping the Sun with a blue supergiant would be catastrophic in a very different way. Blue supergiants are among the most massive and luminous stars in the universe. They can be tens of solar masses and hundreds of thousands of times brighter than the Sun. Their surface temperatures reach up to 20,000 to 40,000 Kelvin, giving them a blazing blue-white appearance. If Earth orbited such a star at its current distance, it would be instantly scorched. The intense radiation would strip away the atmosphere and boil the oceans in a matter of hours. Even the rocky crust would melt under the relentless heat. Blue supergiants also live very short lives, just a few million years before collapsing in a supernova. In such a system, not only would life be impossible, but the planets themselves would be doomed to destruction when the star exploded, scattering their remains into interstellar space. Brown dwarf. If the Sun were replaced with a brown dwarf, the opposite problem would occur. A brown dwarf is sometimes called a failed star because it never gained enough mass to sustain nuclear fusion of hydrogen. They typically have between 13 and 80 times the mass of Jupiter, making them larger than planets, but smaller than stars. A brown dwarf emits very little visible light, mostly infrared radiation. From Earth, the sky would go dark, with only a faint reddish-brown glow replacing the Sun's brilliance. The lack of sufficient energy would cause Earth's surface to freeze rapidly, similar to the effect of a white dwarf but even colder and darker. Gravitationally, because a brown dwarf is less massive than the Sun, planetary orbits would shift outward. Earth and the other planets would drift into larger, less stable paths. Combined with the lack of heat and light, the solar system would quickly become a frozen wasteland. Quasar. If the Sun were swapped with the central engine of a quasar, the results would be violently destructive. A quasar is powered by a supermassive black hole actively consuming matter. As gas and dust fall toward the black hole, they form an accretion disk that heats up to millions of degrees and emits torrents of radiation across the spectrum. Replacing the Sun with such an object would immediately flood the solar system with intense X-rays, ultraviolet light, and gamma rays. The radiation output of even a modest quasar can exceed that of an entire galaxy. Earth's surface would be sterilized almost instantly, and the atmosphere would be blown away. Additionally, quasars often produce relativistic jets, narrow beams of particles moving near the speed of light. If one of these jets were pointed in Earth's direction, it would shred the planet's surface with energy levels that no biosphere could survive. Magnetar. Finally, consider a magnetar. A magnetar is a type of neutron star with an unimaginably powerful magnetic field, up to a quadrillion times stronger than Earth's. These objects are rare, but represent some of the most extreme environments in the universe. If a magnetar took the Sun's place, its mass would be similar to that of a neutron star, so orbits would remain gravitationally stable. But the consequences would come from its magnetic field and radiation. The field is so strong that it could disrupt the structure of atoms at close range. Electronics on Earth would be destroyed instantly, and the planet's own magnetic field would collapse under the strain. Magnetars also emit bursts of high-energy radiation. A single flare could release more energy in a second than the Sun does in 100,000 years. Such a pulse would incinerate Earth's atmosphere and surface in an instant. The solar system would remain structurally intact, but any chance of life would be erased.